Stars produce unthinkable amounts of energy for billions of years. But how? Stars use a process called fusion, when the nuclei combine to form larger masses. In stars' case, hydrogen to helium. Stars are so hot that it speeds up particles, allowing them to overcome their repelling forces and collide into one another. This fusion releases large amounts of energy and a new, larger particle. Since there's so much hydrogen in the sun, this occurs all the time. In stars, two hydrogen atoms collide, causing a hydrogen atom with a proton and a neutron, and releases a positron and a neutrino, and also heat energy. Next, another hydrogen atom fuses with it and forms a 3-2 helium atom and releases gamma radiation. This rare process happens all the time. Then the 3-2 helium particles collide to form a 4-2 helium particle and release 2 protons and gamma radiation. This is the equation for fusion in stars. First, you have the two hydrogen atoms form a 2-1 hydrogen atom plus a positron and heat energy. That becomes added to one other hydrogen atom plus the previous 2-1 hydrogen atom to form a 3-2 helium atom plus gamma radiation. That 3-2 helium atom combines with another 3-2 helium atom and forms a 4-2 helium atom plus 2 hydrogen atoms and lots of gamma radiation. The sun loses 4,300,000,000 kilograms per second, being converted into energy. The equation for energy is E equals mc squared. As many of you don't know, c stands for constant, or the speed of light. But this is even more energy than you think, as 4,300,000,000 times the speed of light equals a huge amount of energy. So what happens once all the energy has been fused from its core? Deprived of energy production needs to support it, the core begins to collapse upon itself and becomes much hotter. Hydrogen is still available in the outside shells around the core, so hydrogen fusion continues. The increasingly hot core pushes the outer layers outwards and causes them to cool, transforming it into a red giant. If the star is sufficiently massive, the collapsing core may become hot enough to support more exotic nuclear reactions, consuming helium to produce elements up to iron. However, such reactions offer only temporary fuel. The inside of the stars become increasingly unstable, sometimes burning furiously, other times dying down. These variations cause the star to pulsate and throwing off its outer layers, cocooning itself in gas and dust. What happens next depends on the size of the core. Average stars become white dwarfs. White dwarfs become novas. and supernovas. Supernovas become neutron stars or black holes. What are those, you ask? Well, that's a different lesson.